Okay, I wanted to make a bit of a comparison here with these meters. There's only one of these meters is a true RMS meter, and we'll talk about RMS in a little bit. Okay, this DL49 UEI, not an RMS meter, fairly new meter. This is an old Fluke 333. This thing, I think it got in the middle 90s. It's been pumping out ever since. The difference between these two, this one reads in hundredths of an amps on the clamp amps, and this one only reads in tenths. Okay, the other one's a field piece. Now this is the only true RMS meter, and it's a SC260. This is a pretty new meter. What I'm going to do is I'm going to clamp different types of loads, and let's see what the different meters show. Because what the selling point of the RMS meter, and I suppose I should explain, RMS is root mean square. Okay, now that you know everything in the world about RMS. Okay, obviously you don't know all there is to know about RMS. But the non-RMS meters have trouble reading the different waves that are coming from electronic parts. The sine waves that come from them are not 50 or 60 cycles. They could be 300 or 400. There's some inductor issues that put pulses back in the line, and they have trouble reading it. So I was just going to compare these older meters with the new true RMS meter. Okay, our first load is going to be an incandescent light. It's a big one. Okay. So we're reading about 3.5 amps. Okay? That's on the 333. The DL49 is taking 3.3. Okay. The true RMS SC260 is showing 3.6. From 3.3 to 3.6, so actually about 0.3 of an amp in variation. Now let's try a different load. Okay, this is a little bit lower amp draw load, the 333. 0.9 amps. The UEI, essentially 0.9 amps. Okay. Whoa. 1.4. So what was the difference between the two loads? Well, the first one was simply a halogen light, a 500 watt halogen light. And the second load I did was an LED load. I have some high intensity LEDs here. And the reason we got a different reading between the two, and these two meters here were actually under reading what the amp draw was, is because they can't read the varying hertz or cycles per second that an electronic load provides. This one can. And so they oftentimes under-read if you're reading on electronic loads. Now understand about LEDs. Most of them don't run on 120 volts. They run on anywhere from 12 to 36 volts. And we use switching controllers to reduce that voltage. Well, a switching controller is kind of, it turns it on, turns it off. Of course, it's DC. It's not the same 50, 60 cycles per second that these meters were meant to read. And it confuses them. So, when we're looking at something that is an electronic load, we're probably going to have to use the true RMS meter. I'm going to do some other comparisons with these meters, with different loads, furnace type loads and the like, and we'll see if there's any difference there. Okay, I wanted to make a bit of a comparison here with these meters. There's only one of these meters is a true RMS meter, and we'll talk about RMS in a little bit. Okay, this DL49 UEI, not an RMS meter, fairly new meter. This is an old Fluke 333.